Hey Geometry, today we're going to get into section 4.3, congruent triangles. So congruent polygons, any shape that's made with straight sides, but we're going to focus in on triangles. We know that all corresponding sides and angles are congruent. All right, so an example of some congruent triangles. So we have two triangles here being marked as congruent: A, B, C congruent to D, E, F. And so we have corresponding angles that are congruent. So angle A corresponds with angle D. So angle A is I guess the corresponding, they are congruent. We'll get to that for a second. But so basically I'm just going to say A and D go together, and then angle B and angle E go together. Those are the corresponding. You see how they're marked congruent here, but C goes with F, so angle C and angle F. So those are our corresponding angles. We also, and then there are going to be congruent, and then we also have corresponding sides. So segment AB is going to be corresponding with so AB goes with DE, side DE, and then we could say BC, segment BC goes with so what does BC goes with? BC goes with EF. And then, so BC goes with EF, and then finally segment CA, which we could also call it AC, and then that probably would be more proper. A lot of times we like to put those in alphabetical order when given the choice, but I'll call it CA. I'm kind of just going around the triangle, goes with FD. So CA, FD, let me get all the proper symbols in there, and those are our corresponding parts. All right, so to name a polygon, there is a standard way of naming it. So we should name the points in clockwise order. That's kind of a standard naming convention. And that's going to be kind of our reference. We don't always stick to that though, because like if you notice here, they labeled this one A, B, C. They're kind of going around there, A, B, C. But when they went with this other one, they actually went in counterclockwise order. So it seems like they're kind of breaking the rule. But that's kind of our default. But the order does matter. In a congruence statement, the order of the vertices, or the points, vertices, indicates the corresponding parts. So usually we kind of go clockwise default. But now we're going to make sure we indicate what parts are corresponding. So when you write a statement such as ABC is congruent to DEF, you are stating which parts are congruent. So part A goes with part D, part B goes with part E, and part C goes with part F, right? So we're kind of indicating the connection between those ones. Notice that A was congruent to D, and so on. So that's what we're trying to indicate this. So given that triangle RST over here, notice that's kind of going clockwise order, is congruent to ABC, so that one happens to be as well, but R goes with A. So when we identify the corresponding marks, what that means is that angle R is going to go with, it's going to be congruent to angle A. And then S goes with B. Angle S is congruent to angle B. And T is congruent to angle C. Angle T is going to be congruent to angle C. And not only that, we also indicate the segments, so kind of between the two. So like segment RS, if I kind of go with those, RS is going to go with AB. So RS is congruent to AB. And then ST goes with BC. So ST, BC, and get those symbols in there. And then finally, like TR, and we could have gone RT, it doesn't really matter, but TR goes with CA. and it's kind of the corresponding parts of that triangle. And I was able to kind of do that without looking over here, without thinking about it on the picture. But it should be true. Like angle R goes with A, so angle R is congruent to A. S is congruent to B. T, I'll do 3 arcs there, and this is how we mark that they're congruent. T is congruent to C, but then also RS, so from here to here, is congruent to A to B. This thing's basically just been like rotated 180 degrees here. ST goes with BC, and then finally TR goes with CA, or you could reverse that. RT goes with AC or whatever. But there we have all of our corresponding parts. So in the next one, write a congruent statement for the congruent triangles. Which triangles are congruent. So I've got like A is the same as E here, B, C. So actually, the nice thing about this is you can always just kind of start with one of the triangles. I've got triangle ABC, and I'm just going to label it that way. And then I got to make sure my other one lines up. So I'm going to say this is congruent to triangle, and I got to make sure I line it up. So A was the first letter I use. E should be the first letter I use here, because that's the corresponding part in the second triangle. So A, and then B was next, so we're going to go D next. So B's got the 2 arcs here. D corresponds to it. And then C actually corresponds to itself, and since they are vertical angles here in that triangle. And those kind of segments all line up and everything there. That's the statement we would have with this one. All right, so for this next one, let's pick one of our triangles. So I'll go with triangle, I'll do this G, I'll start with G and just do this triangle up here. So G, and you really could do this anyway, GHK. I'll go around there in the clockwise kind of standard direction. But when we write this as congruent, I want to make sure I get the corresponding parts. So GHK, I know that that's going to end up being congruent, and we may not actually realize, like I know that H goes with J, so I'm going to put this over here, kind of my middle one. H goes with J. From the angles, it's kind of hard to see here. We have here is like this angle here is actually congruent to that one. We have these end up being parallel lines. There's a whole bunch of ways we could get through this, but we have alternate interior angles. But I do know that H goes with J. Those are both in my right triangle, so that's going to be my middle letter. But then also I have like GH goes with KJ. Like this segment is that one. So GH, KJ, GH, KJ, right? So I know that it has to be in that order, and that K ends up being the same angle there. And then finally, our last letter here, we go, it's K, J, and then G. G ends up corresponding to K, and this ends up being the same angle as that angle in those particular triangles, right? So this is in this first triangle up here. If this is like triangle 1, and that's like triangle 2. All right, so we're going to use some congruent triangles to solve. We know triangle ABC is congruent to triangle DEF, so we're going to find the missing values. And we've got some angles over here, and we've got some lengths over here. Well, this angle up here, if I start with, actually we got 2 things. We got an unknown angle over here, and we got an unknown side. But that side has 2 variables. I'd rather stick away from the 2 variables. Let's work with the 1 variable first. I know that this angle F corresponds to B. So I can say 99, this measure, is the exact same as 8y minus 5. And we can solve that and figure out what y is. So we'll add 5 to both sides. So we'll get 8y equals 104. And then we'll divide both sides by 8. So 104 divided by 8 is not a nice number. Let me get this plugged in. All right, never mind. It is nice. It is 104 divided by 8 is 13. Don't know what I'm doing here. Is 13. So 13 is nice. So we know y is 13. That's that. All right, so then the other thing we can set up here is we know that this FE corresponds to BC, and so that segment there. 38.4 equals 2y plus x. Well, we figured out what y is, so we can plug that in. So 38.4 is equal to 2 times 13 plus x. So 38.4 is equal to 26 plus x. We subtract 26 from both sides, so we get x is, and that's going to be 12.4 to finish solving that one out.